Introducing the right behavior. Once you know that all method binding in Java happens polymorphically, while late binding, you can write your code to talk to the base class and know that all the derived class cases will work correctly using the same code. Or to put it another way, you send a message to an object and let the object figure out the right thing to do. The classic example in OP is this shape example. This is commonly used because it is easy to visualize, but unfortunately, it can confuse novice programmers into thinking that OP is just for graphics programming, which is of course not the case. The shape example has a base class called shape and various derived types: cycle, square, triangle, etc. The reason the example works so well is that it's easy to say a cycle is a type of shape and be understood. The inheritance diagram shows the relationships. The upcast could occur in a statement as simple as shape as new cycle. Here, a cycle object is created and the resulting reference is immediately assigned to a shape, which would seem to be an error, assigning one type to another, and yet it's fine because a cycle is a shape by inheritance. So the compiler agrees with the statement and doesn't issue an error message. Suppose you call one of the base class methods that have been overridden in the derived classes as .draw. Again, you might expect that shapes draw is called because this is after all a shape reference. So how could the compiler know to do anything else? And yet the proper cycle .draw is called because of late binding polymorphism. The following example puts it a slightly different way. First, let's create a reusable library of shape types. The base class shape establishes the common interface to anything inherited from shape. That is, all shapes can be drawn and erased. The derived classes override these definitions to provide unique behavior for each specific type of shape. Random shape generator is a kind of factory that produces a reference to a randomly selected shape object each time you call its next method. Note that the upcasting happens in the return statements, each of which takes a reference to a cycle, square, or triangle, and sends it out of next at the return type shape. So whenever you call next, you never get a chance to see what specific type it is, since you always get back a plain shape reference. Main contains an array of shape references filled through calls to random shape generator.next. At this point you know you have shapes, but you don't know anything more specific than that, and neither does the compiler. However, when you step through this array and call draw for each one, the correct type-specific behavior magically occurs, as you can see from the output when you run the program. The point of creating the shapes randomly is to drive home the understanding that the compiler can have no special knowledge that allows it to make the correct calls at compile time, and the calls to draw must be made through dynamic binding. Exercise 2. Add the override annotation to the shape example. Exercise 3. Add a new method in the base class of shapes.java that prints a message, but don't override it in the derived classes. Explain what happens. Now override it in one of the derived classes but not the others, and see what happens. Finally, override it in all the derived classes. The final version overrides print in all classes, defining print in only the base class returns in. Nothing overrides the base class definition, so it is used everywhere. Overriding print in cycle produces anywhere that we override, we use that version as in cycle. Otherwise, we use the default base class version. Exercise 4. Add a new type of shape to shapes.java and verify in main that polymorphism works for your new type as it does in the old types. The other shape definitions are in the same package, so we just add the new shape and override the methods. The code in the for loop is unchanged from the previous example. Exercise 5. Starting from exercise 1, add the wheels method in cycle, which returns the number of wheels. Modify right to call wheels and verify that polymorphism works. Cycle defines wheels to return 0. In later chapters of you'll learn better ways to specify wheels that using a dummy implementation.